Okay guys, today we are going to continue on with finding missing side lengths using sine, cosine and tangent, but in a slightly different way. So again, trigonometry, sine, cosine and tangent, finding missing side lengths, but I'm going to make it a little bit more difficult. So let's begin. What have we looked at so far and what are we doing? Well, last lesson we looked at using sine, tan and cos to find missing sides. It was pretty straightforward. We had SOHCAHTOA, we looked at our diagram, we were given an angle on one measurement and asked to find the other. We looked at the side length that we were given, we looked at the side length that we were trying to find, and then we made a judgment as to whether we used sine, cos or tan. Okay, we substituted the angle in, pretty straightforward. Rearranged the equation, got the answer. Okay. It was pretty easy. Today we're going to have a look at exactly the same thing, but a little bit more tricky. So this is the kind of thing we were looking at last lesson. We've been given an angle, we've been given two side lengths. We saw that it was the hypotenuse and the opposite, so we pick sine, okay? We put the angle in, sine 38, opposite over hypotenuse. We substitute it in, okay, at this point. Now, at this point, it was really quite easy because the thing that I was missing was my numerator. It was on top. So all I had to do was multiply both sides by 7, which would cancel out the 7 there, in order to find out x. Today, what we're going to have a look at is something a little bit different. We're going to have a look at, okay, this time I'm not going to have the numerator, I'm going to have the denominator unknown. How do I find out an unknown if it's on my denominator? Let's have a look. I get given this diagram here. The first thing I write down is SOHCAHTOA. Okay? It's asking me to find the length of x. Okay? I label my sides. I have my adjacent, I have my opposite, and I have my hypotenuse. Okay? So I have a 30-degree angle, I get given the adjacent and the hypotenuse. I look to SOHCAHTOA and it tells me that cosine is the rule that I need to be using. Okay. So exactly like last lesson, cosine of 30 degrees here is equal to my adjacent over my hypotenuse. The cosine of 30 degrees, and let's substitute in, my adjacent is 5, and my hypotenuse is x. Okay, this is the problem. Okay, the aim of my equation is to get x by itself. Okay, but x is on the denominator here, so I can't pull the 5 away from it just yet because that's saying 5 divided by x, not x divided by 5. Okay, so watch what I'm going to do. Okay, the first thing I know is I need to get the only thing I can do with this right hand side is multiply both sides by the denominator. It's the only thing I can do. So I'm going to multiply both sides by x to see where this can get me. Okay, so if I multiply both sides by x, I get cosine 30 multiplied by x is equivalent to 5. Okay, because divided by x multiplied crosses each other out, and I've multiplied this side by x. Now if I try and get x by itself, this is my aim, to get x by itself. If this left-hand side is saying cosine of 30 multiplied by x, to get that x by itself, I have to divide both sides by the cosine of 30. And if I do that, if I divide both sides by the cosine of 30, okay, if I divide that by, that'll cancel that out, and it'll be 5 divided by the cosine of 30. So x will be equal to 5 divided by the cosine of 30, which gives me an answer of x is equal to 32.41. Okay, if you're a little bit lost, don't worry, let's stick through for another example. Okay, this time I've been given different side lengths. Okay, and if I look through, I've been given, let's label my sides adjacent, opposite, and hypotenuse. I've been given the opposite and the hypotenuse. Okay, so if I write down SOHCAHTOA, SOHCAHTOA, sorry that was a bit dodgy, but you get it. SOHCAHTOA, I know I have the opposite and the hypotenuse. Opposite and hypotenuse, so I know I need to use my sine rule. Sine 35 is equal to my opposite over my hypotenuse. The sine of 35 is equal to 5 on x. The sine of 35, now I need to multiply both sides by x. I multiply that by x, and I multiply that by x. Okay, the sine of 35 multiplied by x is equal to 5. Okay, and then to get that x by itself, I need to divide both sides because I'm doing the opposite of multiplication here. To get that x by itself, therefore, x equals 5 divided by the sine of 35. X is equal to 8.72. Okay, 8.72, that's to 2 decimal places. So, identify the sides, multiply both sides by x, or whatever is on my denominator. Then I need to divide both sides by the sine of 35 there. So then I divided both sides by the sine of 35 because it was the inverse. Last example, let's label my sides. Here's my angle, which makes that the adjacent, that the opposite, and that the hypotenuse. Okay, and I'm asked to find the length of x. Remember, x, not y. X, not y. Okay, I've put a y in this question just to trick you. Okay, now I've been given my opposite and my adjacent. So when I write down my formula, SOHCAHTOA, I know I need to use my tangent rule. Tan of 28 degrees is equal to my opposite over my adjacent. The tan of 28 degrees is equal, substitute into my formula, 19 on x. Okay, I then multiply both sides by x, okay, to get rid of the x on this side. I multiply both sides by x, so I get the tan of 28 degrees multiplied by x is equal to, those cancel each other out, 19. Therefore, to get my x, I do the inverse, it's tan 28 multiplied by x. To get the x by itself, I simply go x is equal to, I divide both sides by x. 19 divided by the tan of 28 degrees, which will give me an answer of, to 2 decimal places, 35.73. And that's it, guys. That's as simple as it is.